Hello everyone, my name is Samir Kumar Singh. Today we will discuss the Big 10 tutorial. Okay, so question number one is on the screen, and that is in DSS system with a length of spreading sequence Q, which of the following is true regarding the frequency response of the DSS plus pulse shaping signals? We have to which of the following is true regarding of the frequency response? So please try this. We have a length of spreading sequences Q. So just tell me which option is true. First one is the bandwidth gets selected by Q. Bandwidth gets selected by 1 upon Q square, both A and B, and these none of the above. Okay, and the right answer option is the C part. Then explanation of question is in DSS system, bandwidth gets selected by the Q, and the frequency response magnitude is scaled by 1 upon Q square. So with both A and B are correct. Sorry. So C is the right answer. Question number two is what is the bandwidth of the DSS system with a spreading factor Q and symbol time is 8 microsecond. Here we have the spreading factor Q and the symbol time. You have to calculate the bandwidth. Please try this. And try to calculate the bandwidth of the system. Again I am repeating this question. What is the bandwidth of DSS system with a splitting factor Q is equal to 32 and the symbol time is 8 microsecond? If anyone got the answer, can comment. Okay, basically we have the symbol duration. We have to calculate the bandwidth. Bandwidth is equal to 1 upon Tc, and we can write the Tc is Ts by Q, and Q spin factor is given 32, and symbol duration is the 8 into 10 to the power minus 6. Just it will be 4 megahertz. So bandwidth would be C, 4 megahertz, and that is the C part. Okay. Next question number 3 is what is the symbol duration of DSS system with the splitting factor Q and chip duration is 16 microsecond. Last question we are calculating the bandwidth, and here we have to calculate the symbol duration. Chip duration is given and the spreading factor is given. Let's use the basic formulas of CDMS. Again I am repeating, the question is what is the symbol duration of a DSS system with the splitting factor Q is equal to 32 and chip duration is 16 microsecond. We have a spreading factor and chip duration. Okay, so we have to calculate the symbol duration. Okay, then symbol duration is equal to Ts is equal to Q into Tc, and Q is the spreading factor, that is 32, and Tc is the 16 microsecond. Just multiply the 32 with the 16 and it will become 5.2 microsecond. Okay, so C part is the right answer. Question number 4 is the which of the following is as an advantage of the DSS system? And option R, it reduces the interference due to other user by using orthogonal codes. It is less likely to be intercepted. It's overcome the effect of frequency selected fading. And these the all of the above are advantages of the DSS system. Reasoning question. Again, which of the following is an advantages of the DSSS system? Question is, it reduces the interference due to other users by using orthogonal codes. B is that it is less likely to be intercepted. It's overcome the effect of the frequency selective fading. And D is the all of the above advantages of the DSS system. So all other advantages of the DSS system, it will be D part. And broadly explain this section will broadly explain the DSS system. Spreading codes used in DSS are very close to the uncorrelated. Thus, only the corresponding user signal will have high energy when a multi-user DSS signal is correlated with a particular user's spreading code. Other user signal can be equivalently treated as a noise. Okay. Next is spread spectrum signal are less likely to be intercepted than other signals because their amplitude is so low. Okay, and that they are comparable to noise amplitude. Hence, unless the stopper knows the spreading codes, they cannot intercept the signals. That this is the major advantage of the spectrum techniques. Next is the frequency selective fading channel has a lot of multipath component. The rack receiver take advantages of these multipath component. Thus, frequency selective fading is helpful. Okay, so for D part is the right. So now question number 5 is, which are given a pulse GT is equal to rect t minus 2 upon capital T, the Fourier transform of the GT. Just use the basic formulas of the Fourier transform and try to find the Fourier transform of this pulse. Pulse is the GT. Second time I'm telling you, just first find out the Fourier transform rect t, and then it is substituted by the t by 2. Please try. Again, the pulse is given, that is GT. To find the Fourier transform of the GT is. Okay, so firstly you all know that just assume that transform we take xt and its Fourier transform is xf. So if you shift xt by t minus t minus tau, it's so there it will multiply by the e, e is to power minus j 2 pi of tau. In time domain you shifted it by tau. In frequency domain you just multiply the exponential terms. Okay, now firstly we find the Fourier transform rect t, rect t by capital T. Okay, so it will become sync function, and it will become at sync ft. Okay, and our input is the shifted by the tau, so it will become at sync ft e to power minus j 2 pi tau. Okay, just due to shifting of the tau, this term is coming. Okay, but in our input signal our amplitude is the 1, so is we will put a is equal to 1 and tau will replace by the t by 2. because here tau is the t by 2 and here input is the and amplitude is the 1. Okay, so it will become capital T sinc f tau e to power minus j pi f tau ft. Okay, you can arrange them and it will become this. So A part is the right answer. Question number 6 is related with the previous question. In the above question, the first zero crossing of the GF mod GF occurs at the frequency of. You have to calculate the first zero crossing. You have GF, just calculate the mod of GF and plot them and, and, and let me know which when you are getting the first zero crossings. Simply calculate the magnitude of the GF and put that is equal to the 0. From there you will get your first zero crossings. So please try this. Okay, so if you see the output of the question, it's coming T sinc f t to power minus j pi f t. So to find the first zero crossing, you just equate this term equal to the 0. Okay, so you just consider this sync function, and for ft is equal to 0, f should be equal to the n upon t, and n belong to z. Okay, therefore the first 0 occurs at the f is equal to 1 by t, and n belong to the z. So it will be A part, because when you plot the sync function, you will able to get it. Next question number 7 is assume two random sequences x and y, each length q. Okay, what would be the power of the interference between these sequences when there is a unit lag? Both random sequences have a unit lag and having the length is q. You have to calculate what would be the power of the interference between these sequences when there is a unit lag. Try this. Again I am repeating. Question is assume two random sequences x and y, each length q. What would be the power of interference between these sequences when there is a unit lag? Okay, according to question, we have two random sequences x and y, and they both have a 1 unit lag. Okay, so we have to calculate the what would be the power of interference. So firstly we will calculate the autocorrelation between these two symbols. Both sequences have the q lengths. Okay, from there if you write this function, it will come to look like that. Okay, now you have to calculate the power of interference. So just from there we will calculate the power of the interference. So you can write this. Okay, x l y into l minus 1. From there when you arrange this, it will come and look like that. Okay, so the power of both signal is the it will become 1. Okay, or it's and limit is going from 0 to q minus 1, so it will come q. So q is cancelled by 1 upon q square, so it will become 1 upon q. So it will be 1 upon q, where q is the length. This type of power, this power would be interference. Next question number 8 is what will the result of the autocorrelation of an M sequence with itself with 0 lag? Now you have to calculate autocorrelation. Okay, and M sequences, the length of the sequence is M with itself with 0 lag. So please try this. It's also same as the previous concept. Okay, so according to the question, okay, the signal we have to get autocorrelation. Both uh, this is XL and this is X is accepted by the minus K. Okay, for 0 lag, they have a 0 lag, so it will become 0. So when you put K is equal to 0, okay, so it will become XL into X star L. From the by the using the summation limit, it will become Q, so it will become 1. You here we are calculating the autocorrelation as it is coming 1. So answer will be the B part. Now consider M sequences with M is equal to 4. Assume that all of the 15 different sequences are to 15 other users. What can be potential problem in doing so in a multi-part environment? So try this. Consider M sequences with M is equal to 4. Assume that all of the 15 different sequences are to 15 other users. What can be potential problems in doing so in much a multi-part environment? This try this. Therefore option. And this is the case of the multi-path environment. Again, consider M sequences with M is equal to 4. Assume that all of the 15 different sequences are to 15 other users. What can be potential problem in doing so in multipath environment? Okay. Sorry, option is the A part, and we will see. Okay, first is given there would be no way of the distinction between signals which are multipath or the same users from the signals of the other user. Next is the system cannot handle the multi-user interference. Is it wrong? C is about A and B. It's also wrong. And answer is the A part. Next is that which of the following statement is correct for the scrambling encryption in the context of the CDMA? Here I just let me know what is the role of a scrambling, what is the difference between scrambling and encryptions in the context of the CDMA. There are four options. First option is the MEM sequences are used in CDMA 2000 for scrambling. The reverse operation is easy for the scrambling but hard for the encryption. C is the both A and B. The scrambling and encryption are different names for the same process. Just use the intuition. Again, I'm repeating, which of the following statements is correct about the scrambling and encryption in the context of the CDMA? First is the M sequences are used in CDMA 2000 for the scrambling. Then the reverse operation is easy for the scrambling but hard for the encryption. C is the both A and B. D is the scrambling and encryption are different names for the same process. The answer is the C part. Okay, because reverse operation of is easy for the scrambling but hard for the encryption. The B is right. M sequences are used in CDMA scrambling. Okay, it's also say true. C is wrong. C is true, and then D is the scrambling and encryption are different names for the process. Same process is wrong. Both processes are very different. Okay. Next question is the which of the four logic channel is used for the channel estimation in the CDMA 2000? Which of the four logic channel is used for the channel estimation in CDMA? Basically, we have four logic channels. First, the pilot channel, synchronization channel, phasing, and tracking channel. Okay. So here you have to tell which of the four logic channel is used for the channel estimation in the CDMA 2000. Okay. Please try. Okay. So answer is A part. Basically, every channels have a different purpose. For the channel estimation, we are using the pilot channels. Okay. So A part is the correct option. Next is the which of the following carriers system information and information regarding PN sequences in the CDMA 2000? Again, we are asking what is the role of the channels, why we are using this, and what is the purpose. Then question is which of the following carriers system information and information regarding PN sequences in CDMA 2000? From there we can get the information, carrier system information and information regarding PN sequences. For this we are using which channels? Pilot channel, synchronization channel, phasing, and fourth the traffic channel. Okay. Please try. Again, which of the following carrier system information and information regarding PN sequences in a CDMA 2000? Okay. From the synchronization channels, we can get the information about the carrier systems, and we can know about the PN sequences. So for the synchronization channel, from the synchronization channel, we can get this. Okay. And last we discussed about the paging pilot channel. This is used for the channel estimation. Here we know the role of the synchronization channel. Okay. Next question is which of the following is the difference between WCDMA and CDMA 2000? Please let me know which of the following is the difference between the WCDMA and CDMA 2000. Again, which of the following is difference between WCDMA and CDMA 2000? WCDMA can support spreading sequences of the variable length, but CDMA 2000, sorry, it's 2000 can WCDMA can support multiple chiplet, but CDMA 2000 supports only one chiplet. C is the both A and B. These are neither A or B. Please comment. Okay. So major differences. C is the right option. Okay. Basically, WCDMA ka role, what basically the role of WCDMA, it can support splitting sequence of a variable length, but CDMA 2000 can't. CDMA can support a multiple chiplet, but CDMA 2000 support only one chiplet. Okay. This is a major advantage of the WCDMA. So C is the right answer. Question number 14. For CDMA 2000, base station codes are separated by 16 n codes, where n is an integer. Consider n is equal to 2 and assume that 2 is to 15 length shortcuts are used. The maximum number of supported base stations are. Okay. Here you have to calculate the maximum number of supported base stations. Again, I'm repeating, for CDMA 2000, base station codes are separated by 64 n codes, where n is an integer. Consider n is equal to 2 and assume that 2 is to 15 length shortcuts are used. The maximum number of supported base stations are. Again, for CDMA 2000, base station codes are separated by 64 n codes, where n is an integer. Consider n is equal to 2 and assume that 2 to power 15 length shortcuts are used. The maximum number of supported base stations are. Okay. So number of the base stations is equal to 2 is to 15 upon 128. So it will become 256, and at 215 is the length, total length, and base station codes are 64n, and n is the 2. Okay, so it will become 128, and there's a total number of codes. So number of base station will become 256. So C part is the right answer. Question number 15 is the statement type question. Consider the following statement for the orthogonal variable spreading factor code. Okay, so statement 1 is, if a code is assigned, its successor cannot be assigned. If code is assigned, its predecessor can be assigned. Here we are talking about the orthogonal variable spreading factor code. Okay, so you let me know which statement is true. Sorry, which option is the true? Both statement true, or one is true, two is false, two is true, or one is false, or both are false. Please try it. You can comment. Okay, so right option is the C part. Basically, this is the beauty, or you can say advantage, of the orthogonal variable cycle code. If a code is assigned, its successor can't be assigned. Okay, and if a code is assigned, its predecessor can be assigned. So statement 1 is the true and statement 2 is the false. It's also we can't assign. Okay, C is the right answer. Next, the question also is related to previous one. The question is, consider the following statement for an orthogonal variable spreading factor code. Okay, and statement this also is statement 9, and they'll, so you will let me know which is the true, which option is correct. Question is, consider the following statements for an orthogonal variable spreading factor code. Orthogonal variable spreading factor codes. Please try this. Consider the following statement for an orthogonal variable spreading factor code. Statement is the orthogonal. First statement is, and this is the second statement. So answer is the A part, is the right option. statement when two is the both are the true. Thank you so much for the joining.